Hey everyone, in today's video we're going to be talking about Unit 1, Lesson 2 of Algebra 2. And in this topic, I believe we are discussing literal equations, interval notation, and solving inequalities. So hope you enjoyed the video. Thank you for watching. Okay, this is Unit 1, Lesson 2. Today we're going to be talking about literal equations, as well as interval notation and graphing inequalities, and just solving plain inequalities. So the first thing I want to cover is literal equations. Okay, so a literal equation is basically an equation with multiple variables. So if you watched the last video, you know that there are some instances where expressions can have multivariables, and those are multivariable expressions. Well, the same thing can happen with equations, with literal equations. So a literal equation just has multiple variables. So if I take this example right here, so I say x minus 2 over 2, and I say equals m plus n. Just random variables, and then I can pick a variable to solve for. So if I want to solve for x, that means I'm going to solve for this x right here. And again, the goal of an equation is to isolate the variable. In this case, there are multiple variables, so we isolate the variable we're solving for. So how do we do that? So the first step is we're going to multiply by 2 to get this division out of the way. So we're going to multiply this whole thing by 2. We're going to multiply this whole thing by 2 as well. So when I do this, I'm going to get x minus 2 is going to be equal to 2m plus 2n, because we can distribute that 2. And the last step is to add 2 to both sides, because as you can see, that would isolate the x variable. So we get 2m plus 2n plus 2, and that's our answer. So when you're solving literal equations, you may also be asked to solve for different variables. So we're gonna do a different variable this time. Let's try maybe m or n. Let's try m. So if I have x minus 2 over 2, and I have equals m plus n. So if I solve for m, this is actually very easy. All I have to do is subtract m. Let me write for m. So all I have to do is subtract n from both sides, and this would look like this. X minus 2 over 2 minus n is equal to m, or you could write it m equals x minus 2 over 2 minus n. Either answer is acceptable, but that is how to solve literal equations. And obviously with n, it would be the same except subtracting m, but it would look the same because this one is a simpler one. Yeah. So now we're going to look at something that's probably new, known as interval notation. So interval notation is kind of another way to notate inequalities. So you may have talked about in the past about graphing inequalities. We're going to do some more of that today. But first, let's talk about interval notation and how we can notate that. So interval notation, it reads left to right, which makes sense because it's smallest to highest. Another thing I want to say is when we have a less than or equal to, or a greater than or equal to. This means we're going to have a closed circle on a graph, right? And we're going to have brackets when we have interval notation. And this will make a little bit more sense when we get into some examples. But when we have just less than or greater than here, we have an open circle, right? And then this is going to be represented with parentheses in interval notation. The last thing is whenever you have an infinity, so negative infinity, infinity, and infinity, you're going to have parentheses. So So whenever you have less than or equal to, less than or greater than, or negative infinity or infinity, you're always going to have parentheses when representing that. And what I mean by negative infinity and infinity is when we graph an inequality here, let's just pick, let's do x is greater than 5. When I graph this inequality, this 5 right here, we're going to have an open circle, right? Because of that greater than there. And then it's going to go on in this direction forever, all the way to infinity over there. And so there's where the infinity is right here. Infinity's over here, negative infinity's over here. But infinity is over here. And as you can see, the graph is approaching infinity. So we can say interval notation would look like this. So it'd be parentheses 5, comma, infinity parentheses, because it's a greater than symbol and then it's infinity. So this is what makes it interval notation like that. Okay, we're gonna do another interval notation example or two. Let's do x is less than or equal to -2. So showing this on a graph, right? We're gonna have -2 right here. We're gonna have a closed circle this time, and it's gonna go to negative infinity over here. So this is how to graph it. And then if we write it in interval notation, it's gonna be negative infinity with a parentheses and -2 with a bracket. And it's going to be -2 with a bracket because it's a closed circle and it's less than or equal to. So that's what tells us it's a bracket. So it's not always going to be parentheses, comma, parentheses, or bracket, comma, bracket. It could be comma, or bracket, comma, parentheses, comma, bracket, or bracket, comma, parentheses. It can be any of these four. Now we're going to do a kind of different way of an inequality. So we have 1 is less than or equal to less than x is less than or equal to 8. So when I have my graph right here, we're going to need two values this time. We're one for 1 and 1 for 8, right? So our x is going to be, let's make a open circle first because this is less than, and this means it's going to go on this way. But look, x is less than or equal to 8. So this means we're going to make a closed circle here. So our x value is somewhere within this area. Could be equal to 8, but not equal to 1. So that's what this graph is showing. And that is how interval notation works. So yeah, and the last thing we're going to talk about is solving inequalities. You probably remember how to do this from an earlier class, but we're also going to talk about writing it in interval notation because that's an important skill to learn. So we're going to do, let's do 9x plus 7 is going to be less than or equal to 8x minus 2. Okay, so this is going to be very similar to solving an equation, right? Except now we have a greater than or equal to sign here, an inequality sign, which is going to kind of tell us generally where our solution may be, but it's not going to give us an exact solution. So we're going to solve this just like an equation. Let's subtract 8x from both sides to balance it out. So this is going to give us x minus 7 on both sides to balance it out. Bring the sign down, -9. So x is going to be greater than or equal to -9. So if we graph this, right, we're going to have our -9 right here, and we're going to have a closed circle going on to infinity. And now we can write it in interval notation. It's going to look like this. It's going to look like bracket -9, comma, infinity parentheses. So negative 9 is a closed circle, right? And it's greater than or equal to, so it's going to be a bracket. And we have parentheses over here because it's infinity. And remember, infinity always has to be parentheses because infinity is a concept and a behavior, and it's not an actual number. So it can't really be proved, so that's why we use a parentheses. Let's do another example. So like equations, inequalities can have special examples as well, special cases. So we can have, let's do this one, 5 times 2x minus 3, and then minus 7x is less than or equal to 3x plus 8. So first step is going to be to distribute. We're going to get 10x minus 15 minus 7x. Okay, this is going to be less than or equal to 3x plus 8. So 10x minus 7x is going to be 3x, combined like terms, minus 15 over here, less than or equal to 3x plus 8. When we add 15 to both sides and subtract 3x from both sides, this 3x cancels out over here. Less than or equal to, so this, since this cancels out, we get 0. And 15 plus 8 is 23. Yeah. And 0 is less than or equal to 23. Now, remember in equations, if I had 0 is equal to 23, this were an equation, I would go, this is not true, so this is no solution. But in inequalities, we have to think, is this a true statement? Is 0 less than or equal to 23? And the answer is yes, because if I put the numbers on a number line here, we have 0 over here and 23 over here. And look, 0 is less than 23, less than or equal to. It's not equal to, but it's less than 23 because it comes before 23 on our number line. So that's how we can prove that. So 0 is less than or equal to 23. This is all real numbers or infinite solutions because it is a true statement. There's one more special case with inequalities, and I'm going to show it to you right now. So our next example is going to be 9x plus 7. I'm going to have less than 9x minus 2. Okay, so let's subtract 7 from both sides and subtract 9x from both sides. So this cancels out and this cancels out. So we're going to have 0 as our x over here, and then negative 2 minus 7 is a negative 9. So 0 is less than negative 9. Now, is this a true statement? I'm going to draw my number line to prove it here. No, this is not a true statement. Why? Because negative 9 actually comes before 0 on a number line. So 0 can't be less than negative 9. So this is not a true statement. So this is going to be no solution. So when we're graphing no solution, there's not really much you can do. So it's just going to look like this. You don't have to draw any arrows or anything. And then for the interval notation, you can just write that or not anything. And I think I forgot to mention the, if you had all real solutions here, to graph that, it would look like this. All real solutions, all real numbers would look something like this because it goes on forever in both directions, both to negative infinity and infinity. So our interval notation would just be negative infinity, comma, infinity. And we know that they have parentheses because they're infinities. So that's how that works. And with that, that concludes Unit 1, Lesson 2 of Algebra 2. Thank you for watching. Bye.